Here we have a problem on integration, that is we have to evaluate this indefinite integral, that is integral sine to the fourth power x times cosine square x dx. Okay, in my first step what I am going to do is, let me write it integral. I am going to write this sine to the fourth power x as sine square x whole to the second power times cosine square x times dx. Okay, using the double angle identities of the trigonometric function cosine, we can write the sine square x as 1 negative cosine 2x over 2, and also we can write cosine square x as 1 positive cosine 2x over 2. So we got this stuff for sine square x and cosine square x using the double angle identity of the trigonometric function cosine. Okay, now what I'm going to do is in my work I'm going to replace this sine square x by this stuff, that is 1 negative cosine 2x over 2, which is equal to sine square x. Okay, let me continue over here. Integral 1 negative cosine 2x over 2. Since we have the whole square for sine square, the same whole square has to be taken for this one. And for this cosine square x, we can plug in 1 positive cosine 2x over 2 times dx. Okay, so here in our next step, here we have square for a fraction. Whenever we have a common exponent for a fraction, and the exponent can be distributed for numerator and denominator. When I distribute this exponent 2 for this numerator 1 negative cosine 2x, I am getting 1 negative cosine 2x whole square. When I distribute this exponent 2 to the denominator, it will be 2 square. The value of 2 square is just 4 times 1 positive cosine 2x over 2 times dx. Okay, let me continue over here. Now we can multiply the two constants over here in denominator, that is 4 times 2, it's 8. Since 8 is a constant, it can be moved out of the integral. Since the constant 8 is in denominator, when it comes out of the integral, it will be 1 over 8 times integral 1 negative cosine 2x whole square times 1 positive cosine 2x times dx. Okay, now let me erase the stuff over here. Okay, now I'm going to consider the algebraic identity, that is a negative b the whole square, and its expansion is a square negative 2ab positive b square. I'm going to use this identity over here in the square of the binomial, that is 1 negative cosine 2x whole square, to get the expansion of this one. Okay, now let's compare this one and this a negative b the whole square. At the place of a we have 1, at the place of b we have cosine 2x, and here we have negative sign between a and b, here we have negative sign between a and b. So when I expand this one, I have to use the expression over here. At the place of a in this expression, I have to write 1. At the place of b, I have to write cosine 2x. Okay, now let me continue over here. 1 over 8 times, so let me expand the square of the binomial over here. That is 1 square negative 2 times for a we have to write 1, for b we have to write cosine 2x. Positive cosine 2x whole square, or it can also be known as cosine square 2x times 1 positive cosine 2x dx. Okay, so here 1 over 8 times integral, the evaluation of this 1 square is just 1, 2 times 1 is 2, 2 times cosine 2x is 2 cosine 2x positive cosine square 2x times 1 positive cosine 2x dx. Okay, now what we have to do is inside the integral we have to multiply this trinomial and this binomial. So for that we have to distribute this 1 to this 1 and cosine 2x. When I do so, I am getting 1 positive cosine 2x. I just distributed this 1 to this 1 and 1 to this cosine 2x. So this is the result I am getting. Now I have to distribute this negative 2 cosine 2x to this one and this cosine 2x. When I do so, I am getting negative 2 times cosine 2x. And negative 2 times cosine square 2x, because when I multiply this one and this one, I'm getting negative 2 times cosine square 2x. Okay, now what I have to do is I have to distribute this cosine square 2x to this one and cosine 2x. When I do so, I'm getting a positive cosine square 2x and negative cosine cube 2x dx. Okay, now we can combine the like terms over here inside the integral. So here we can write this one as it is, and here we have a positive cosine 2x, here we have negative cosine 2x. When I combine them, I am getting negative cosine 2x, and also we can combine this negative cosine square 2x and positive cosine square 2x, and then I am getting negative cosine square 2x, and we have to write this one as it is, that is negative cosine cube 2x dx. Okay, now let me continue on the next page. This is the last step we have had on the previous page. Okay, let me continue over here. I take this constant 1 over 8 as it is. Okay, now what I'm going to do is I'm going to distribute this integration to each term inside the parenthesis over here. So when I do so, let me write, so when I distribute this integration to this one has to be multiplied by dx. Then I'm getting integral dx. Now let me take this negative sign as it is. When I distribute this integration sign to this cosine to x, it has to be multiplied by dx. Then I'm getting integral cosine 2x times dx. Now the same thing, I have to take this negative sign as it is. When I distribute this integration to this one, I'm getting integral cosine square 2x times dx. Now let me take this positive sign as it is, integral cosine cube 2x dx. Okay, now this complete stuff is multiplied by the constant 1 over 8. Okay, 1 over 8 times, okay, the integration of dx is just x. And now let me consider the formula to get integration of the trigonometric function cosine. That is integral cosine x dx equals to, we know that it's sine x positive c. Actually, it's a constant of integration. We'll be adding constant of integration whenever we evaluate an indefinite integral. That is, we don't have the lower limit and upper limit. So that's why it's called indefinite integral. Okay, the integration of cosine x is just sine x. Okay, so what if the angle measured x over here is multiplied by some constant, for example, ax? So the integration of cosine of ax dx equals to sine of ax over a positive c. The same thing what we have done over here, the same thing we are doing over here. The integration of cosine is sine, and whatever stuff we have over here, I'm writing this one as it is. And whatever constant is multiplied by the variable x over here, I divide this entire sine x by a. So here, why do I consider this particular integration over here? Because in our integration over here, the variable x is multiplied by the constant 2. So whatever stuff I have done over here in this one, the same thing I have to do to get integration of cosine to x. That is, the integration of cosine is sine, and whatever stuff over here, it has to be written as it is. It has to be divided by the constant which is multiplied by the x over here, then sine to x over 2, and I am writing these two integrations as it is. It is negative integral cosine square 2x dx, positive integral cosine cube 2x dx. Okay, now what I'm going to do is I'm going to evaluate these two indefinite integrals separately. So once I get the results of these two integrals, I'll come back to this step and plug in the results over here for this one and this one. Okay, first let me evaluate this indefinite integral on a new page. Now let's evaluate this indefinite integral, that is integral cosine square 2x dx. Okay, already we have discussed a formula for cosine square x using the double angle formula for the trigonometric function cosine, that is cosine square x equals to 1 positive cosine 2x over 2. Okay, so what's the difference between the cosine square x over here and the cosine square we have in the integral? So here we just have x, but here the variable x is multiplied by the constant 2. Since variable x is multiplied by the constant 2, in the formula also let's multiply the variable over here and here by the constant 2, because when I multiply the variable x by 2 on the left side, on the right side also, wherever I find variable, it has to be multiplied by 2. So then I'm getting cosine square 2x equals to 1 positive cosine 2 times I multiply this variable x by 2, then I'm getting 2x over here divided by 2, then I'm getting cosine square 2x equals to 1 positive cosine 2 times 2x is 4x over 2. Okay, now what I can do is I can plug in this stuff 1 positive cosine 4x over 2 for cosine square 2x that we have over here. Okay, now let me continue with the integration over here. That is integral for this cosine square 2x. We can plug in the stuff, that is 1 positive cosine 4x over 2 times dx. Okay, now what we can do is we can move this constant 2 out of the integration. Since a constant 2 is in denominator, when it comes out, it will be 1 over 2 integral 1 positive cosine 4x times dx. Okay, now 1 over 2. Okay, when I integrate this 1 with respect to x, its integration is just x. And already we have discussed the integration of cosine 4x also on the previous page. So that is a cosine ax, integration of cosine ax dx equals to sine ax over a. That is whatever constant is multiplied by the variable x over here. So here we have to divide the sine ax over by a. Okay, now the same thing. So the integration of cosine is sine, and here we have 4x, the same should be written over here. It has to be divided by the constant which is multiplied by the variable over here, that is x positive sine 4x over 4. We can take the constant of integration at last. If I want, I can write it over here. Otherwise, we can take it at last. Okay, now what we can do is we can distribute this 1 over 2 to this one and this one. Then I'm getting 1 over 2 times x positive. When I distribute this 1 over 2 to this one, I am getting sine of 4x. That is 1 times sine of 4x is sine 4x. 2 times 4 is 8, positive c. Okay, now I got the result of this integration, that is integral cosine square 2x dx, that is 1 over 2 times x positive sine 4x over 8. Okay, now what we can do is we can plug in this result for this particular integration on the previous page. Okay, let me go to the previous page. Okay, now let me write it over here. 1 over 8 times x negative sine 2x over 2 negative, and for this one only we got the result that is 1 over 2 times x. Let me write it in parentheses because we have negative sign over here. 1 over 2 times x, and also we have sine 4x over 8 positive. Now what we can do is we can evaluate this integration separately, and again we can come back to this step and plug in the result for this integration over here. Okay, now let's evaluate this integration separately. Okay, now let's evaluate this indefinite integral, that is cosine cube 2x dx. Okay, in my first step, what I'm going to do is I'm going to write this cosine cube 2x as cosine square 2x times cosine 2x dx. Okay, now let me consider the Pythagorean identity in trigonometry, that is sine square x positive cosine square x equals to 1. Okay, if I want to solve for cosine square x in this identity, what I have to do is I have to subtract sine square x from both sides. In that case, I'm getting cosine square x equals to 1 negative sine square x. Okay, now I'm going to write this cosine square 2x in terms of sine square using the identity over here. So the difference between this one and this one is here in the identity we have x, in our problem we have 2x. So the same stuff, 1 negative sine square x we have to write over here for this one, but at the place of I just have to write 2x because for x we have 2x over here. Okay, now let me continue over here. Integral. So for this cosine square 2x, we can write 1 negative sine square 2x times, cosine 2x times dx. Okay, integral 1 negative. This sine square 2x can be written as sine 2x the whole square times cosine 2x times dx. Okay, here when I consider this integration, particularly the integral over here, so the derivative of sine 2x is cosine 2x times 2. Anyways, its derivative is almost over here, and also it is multiplied by dx. Okay, so in integration, whenever the derivative of a part of the integral is multiplied in the integral itself, what we can do is we can evaluate such integration by u substitution. Okay, now I'm going to substitute a new variable u for this sine 2x because we got the derivative of the sine 2x over here. Okay, now let me continue with u substitution. That is let u equals to sine 2x. Okay, since I substituted a new variable u for the sine 2x, I have to get this complete integration in terms of the new variable u. When I get the complete integration in terms of the new variable u, I have to get a du at the place of dx, so that I'll be able to evaluate the integration with respect to u. Okay, so at the place of dx, if I want to get du, what should I do with this u? I have to find derivative, so that I'll be getting du. Since we have the original integration with respect to the variable x, now I have to find derivative on both sides in this equation with respect to x. When I find derivative of this u with respect to x, I'm getting du over dx. When I find the derivative of this sine 2x, it's cosine 2x. So usually the derivative of sine is cosine. Okay, so far I have completed derivative only for the trigonometric function sine. By chain rule, I have to do further derivative of this 2x. When I do further derivative of this 2x, it will just become 2. Then I'm getting du over dx equals to, we can write this 2 in front of the cosine 2x over here. Then I'm getting 2 times cosine 2x. Okay, now to solve for du in this equation, I have to get the denominator dx over here. For that, I have to multiply both sides by dx. Let me do it. So when I multiply both sides by dx, this dx will cancel out. I'm getting du equals to 2 times cosine 2x times dx. Okay, let me take the same equation over here. Du equals to 2 times cosine 2x times dx. Okay, when I consider the integration over here, here we have cosine 2x times dx, the same stuff we have over here. But we have 2 multiplied over here. So to get of this 2, what I have to do is I have to divide both sides by 2. When I do so, this 2 will cancel out. And this du over 2 can be written as 1 over 2 times du. On the right side, we have cosine 2x times dx. Okay, now let me continue with the integral over here. Equals to integral 1 negative. For this sine 2x, so what I can do is I can plug in u, then I'm getting a 1 negative u square times for this cosine 2x dx, I can plug in 1 over 2 times du. Let me write it over here. Okay, now 1 over 2 is a constant. It is multiplied by the part which contains variable. In integration, whenever a complete variable part is multiplied by some constant, the constant can be moved out of the integral. Then I'm getting 1 over 2 times integral 1 negative u square times du, and it's a regular polynomial. It can be integrated easily because we have this polynomial in terms of the variable u, and it has to be integrated with respect to u. Okay, let me do it. So when I integrate this 1 with respect to u, I'm getting just u. And when I integrate this u square using the power law of integration, I'm getting u cube over 3. We can add the constant of integration past to c. We can distribute this 1 over 2 to this u and negative u cube over 3. Then I'm getting u over 2 negative. When I distribute this 1 over 2 to this u cube over 3, this 2 times 3 will become 6. Then I'm getting u cube over 6 positive c. Actually, u is a variable taken by us. It has to be replaced by the original stuff, that is sine 2x. So we have to plug in sine 2x for this u over here and here. Then I'm getting, let me write over here. So sine 2x over 2 negative sine 2x the whole cube over 6 positive c. Okay, now I plugged in the sine 2x for this u over here in this step. Now we can write this one as sine 2x over 2 negative. The sine 2x whole cube can be written as sine cube 2x over 6 positive c. Okay, now I have evaluated the integral, that is integral cosine cube 2x dx. Its evaluation is over here. Now we can plug in this result for this integration on the previous page, I mean in the previous step. Okay, now we can plug in the result of this integration over here that we just got it. That is sine 2x over 2 negative sine cube 2x over 6. We have evaluated all the integrals, so now we can add the constant of integration c over here, because even from the beginning we have started evaluating indefinite integral. So whenever we evaluate indefinite integral, at last we have to add the constant of integration. Usually we take c as a constant of integration. Okay, now let's do further simplification of this one. 1 over 8, here we have x negative sine 2x over 2. Now we can distribute this negative sign to this and this. Okay, so when you distribute this negative sign to this one, negative 1 over 2 times x, or it can also be written as x over 2. When you distribute this negative sign to this 1, negative times positive will become negative sine 4x over 8 positive sine 2x over 2 negative sine cube 2x over 6 positive c. Okay, here we can cancel this negative sine 2x over 2 and positive sine 2x over 2. Okay, now let me continue the rest on the next page. This is the last step we have had on the previous page after cancelling out negative sine 2x over 2 and positive sine 2x over 2. Okay, now what I'm going to do is I'm going to combine these two terms, because both the terms are like terms, because both the terms contain x. Okay, now let me do simplification of this one separately, that is x negative x over 2. Okay, now let's assume x as an integer. So that is I'm doing subtraction between an integer and a fraction. Whenever I want to do addition or subtraction between an integer and a fraction, what I have to do is I have to multiply the integer part by the denominator of the fraction. Once I'm done with the multiplication, I can take this 2 as a common denominator. So that is I'm going to multiply this x by this denominator 2, then I'm getting 2x negative x over 2. So 2x negative x is just x over 2. So simplification of this one is x over 2. Let me write it over here. So 1 over 8 times x over 2 negative sine 4x over 8 negative sine cube 2x over 6 positive c. Okay, now what we can do is we can distribute this 1 over 8 to all the terms inside the parentheses over here. When I distribute this 1 over 8 to this x over 2, I have to multiply the two numerators and two denominators. That is, when I multiply this 1 and x, I'm just getting x. 8 times 2 is 16. And now we can take this negative sign as it is. When I distribute this 1 over 8 to this sine 4x over 8, 1 times sine 4x is sine 4x. Divided by 8 times 8 is 64. And now we can take this negative sign as it is. Let's multiply this 1 and sine cube 2x, and I'm getting sine cube 2x over 8 times 6 is 48 positive c. So this is the final result of the given indefinite integral.